You type a question into an AI, and a second later, a perfect answer pops out. It feels like magic, right? Well, it's not magic, but it is an absolutely incredible journey. So today, let's pull back the curtain and see exactly how it all works.
So, what is the secret? I mean, how does a machine really go from the words you typed to a coherent, almost human-like response? That's the exact puzzle we're going to solve together right here, right now.
And here's how we're going to do it. Instead of some high-level, complicated overview, we're going to zoom all the way in. We're going to follow the incredible journey of just one single piece of your text, what the AI world calls a token. Think of it as our little hero for this story.
The second you hit enter on your prompt, our token's great adventure begins. That prompt is the starting pistol for a mad dash through the very core of the AI, a super complex system that's known as the transformer architecture.
But hold on, before our token can even enter that complex core, it needs to get ready. It has to be translated from our human language into the language of machines. It becomes something called a vector, which is basically just a fancy name for a long list of numbers that perfectly captures the word's meaning, its vibe, its essence.
Okay, so this whole gearing up process happens in three main steps. First up is tokenization. This is pretty simple. Your sentence just gets chopped up into those manageable pieces, our tokens. Second is embedding. This is where each token gets its numerical identity, its vector, from a gigantic internal dictionary. And finally, there's positional encoding. This step tells our token exactly where it is in the sentence. Is it the first word, the last, the one in the middle? This is absolutely critical for understanding context.
And the result of all that prep work? Well, this quote just nails it. After this phase, our token isn't just a word anymore. It's now this super sophisticated piece of data that knows both what it is and where it is in the sentence. It's fully equipped and ready for the main event.
All right, our token is prepped and ready. Now it enters the real heart of the machine, a whole stack of processing units called transformer layers. You can think of this as a gauntlet, or maybe a series of intense training levels where each stage is going to make our token way smarter.
And the first and maybe the most important challenge in every single layer is this thing called multi-headed attention. Now this is where the real magic of context happens. It's like a master class in listening. Our token literally looks at every single other token in the sentence to figure out all the relationships. And by doing that, it gets a much better idea of its own job in the grand scheme of things. So inside every single layer, there's this two-step dance that happens. On the one hand, you've got multi-headed attention. Think of this as the group project. It's collaborative. All the tokens are sharing info to build up that shared context. But then right after comes the feed-forward network. This is like quiet solo homework time. Each token takes what it just learned and processes it on its own to really refine its own understanding.
And here's the kicker. This isn't a one-and-done deal. Our token goes through this whole cycle of collaboration and then reflection over and over again, passing through layer after layer. And with each pass, its numerical representation gets richer, more complex, evolving from a simple definition to a really deep, abstract understanding of language.
After surviving that entire gauntlet of transformer layers, our token has been completely transformed. It's now packed with all this rich context and meaning, and it is finally ready to do what it was made to do, help predict what word should come next.
So how does it do that? Well, the token's final, super-enriched vector gets fed into one last part, called a linear layer. And this thing's job is to generate a raw score, they're called logits, for every single word in the AI's massive vocabulary. That score just represents how likely each word is to be the next one in the sequence.
But those raw scores, the logits, are pretty messy and hard to compare. So that's where the final magic touch comes in, a function called softmax. You can think of softmax as a neat freak. It takes all those messy scores and tidies them up, converting them into a clean, simple probability distribution, basically a percentage chance for every possible next word.
And boom, this is what you get at the end. The AI has calculated the exact probability for all the top contenders. In this example, the word journey has the highest shot at 45%. Now here's the cool part. The AI will often pick the top choice, but it doesn't have to. It might pick model or word just to be a little more creative. And that is exactly why you can ask the same prompt twice and get a slightly different answer. Once it picks a word, the whole process starts all over again to predict the next one after that.
So, there we have it. Our token has completed its mission. This journey, from a simple word to a complex, calculated prediction, is the fundamental process that's happening millions of times a second inside the AI models we're all using every single day.
So if you take anything away from this, just remember these 4 key ideas. 1. Words get turned into data. 2. Context is a team sport, that's the attention part. 3. Meaning gets sharpened through solo work. And 4, this one is huge, the final AI output is a set of probabilities, not a single, dead certain answer. In a nutshell, that's the core logic.
We've just tracked a single token predicting a single word. Now just take a second to imagine the same exact process, but it's not happening with one token. It's happening with billions of them, all learning together from trillions of words from basically the entire internet. That immense scale is what gives these models their truly mind-bending power.